Welcome to this comprehensive tutorial on the Splunk Lookup command. The Lookup command is a powerful feature that allows you to enrich your search results by adding fields from external data sources. Think of it as a bridge that connects your raw event data with additional context stored in files like CSV files, key value stores, and lookup tables. This enrichment capability transforms basic data into meaningful insights by adding context, translating codes, and correlating information from multiple sources. By mastering lookups, you can significantly enhance the value and readability of your Splunk search results. Splunk supports three primary types of external data sources for lookup operations. First, we have CSV files, which are static lookup tables stored as comma-separated value files. These are perfect for reference data that doesn't change frequently, such as product catalogs, employee directories, or location mappings. CSV files are easy to maintain and update, making them ideal for most lookup scenarios. Second, we have key value stores, also known as KV stores, which are high-performance NoSQL databases built into Splunk. KV stores excel at handling dynamic data that requires frequent updates and can support large datasets with fast query performance. They're perfect for real-time data scenarios where information needs to be updated regularly. Let's examine the core syntax structure for lookup operations. The basic lookup command follows a specific pattern that begins with the keyword lookup, followed by the table name which refers to your external data source. Next, you specify the lookup field, which is the field in your lookup table that will be matched against your event data. The AS keyword allows you to map this lookup field to a specific field in your events. Finally, the output or output new clause specifies which fields from the lookup table should be added to your search results. For example, if you want to enrich events with product information, you would use lookupproducts.csv, specify product_ID as product ID, and use output new to add the product_name field to your results. CSV file lookups are the most common type of lookup in Splunk due to their simplicity and effectiveness. The CSV structure is straightforward, consisting of a header row that defines field names, followed by data rows with comma-separated values. For instance, a product CSV might contain columns like product_ID, product_name, and price. To use this CSV in a lookup operation, you would reference it by file name in your lookup command. The syntax follows the pattern of lookupproducts.csv, where you match the product_ID field from the CSV to the product ID field in your events, and output new fields like product_name and price. This approach allows you to transform cryptic product codes into meaningful product names and associated pricing information. KV store lookups provide a more advanced and scalable solution for dynamic data scenarios. Before using a KV store for lookups, you must first define the collection structure in your collections.conf configuration file. This definition includes the collection name, accelerated fields for performance, and field definitions with their data types. For example, a user information collection might include fields like user_ID as a string, department as a string, and location as a string. Once configured, you can reference the KV store in lookup commands using the collection name. KV store lookups also provide access to a special _key field, which represents the unique identifier for each record in the collection. This makes KV stores particularly powerful for scenarios requiring real-time updates and high-performance queries. Proper lookup configuration is essential for reliable and efficient lookup operations. For CSV lookups, you need to create entries in your transforms.conf file that define the lookup behavior. A typical CSV lookup definition includes a stanza name that you'll reference in your searches, the file name pointing to your CSV file, and optional settings like case_sensitive_match set to false for flexible matching. KV store configurations follow a similar pattern, but include additional parameters. The external underscore type is set to store, the collection parameter specifies which KV store collection to use, and the fields _list parameter defines which fields should be available for lookup operations. These configuration files serve as the bridge between your lookup commands and the actual data sources. Let's explore some real-world applications of lookup commands. In cybersecurity scenarios, you can enrich IP addresses with threat intelligence data by creating a lookup that matches IP_address fields from your events to a threat intelligence CSV file. This adds valuable context like threat_level and category information to security events, enabling faster threat identification and response. Another common use case involves enriching user activity logs with employee information from HR databases. By matching username fields to an employee's lookup table, you can automatically add department and manager information to access logs, making it easier to track user behavior across organizational boundaries. These examples demonstrate how lookups transform raw log data into actionable intelligence by adding business context. To maximize lookup performance and efficiency, follow these essential best practices. Always use output new instead of output when possible, as this prevents the lookup from overwriting existing fields in your events. Keep CSV lookup files under 25 megabytes for optimal memory usage and performance. For frequently accessed large datasets, consider indexing the lookup data instead of using file-based lookups. When designing your search pipeline, place lookup commands early in the process when possible, as this can improve overall search performance. Use KV stores for dynamic data that changes frequently, as they provide better performance for real-time updates. Finally, regularly clean up unused lookup definitions and files to maintain a tidy Splunk environment. These optimization techniques will ensure your lookups operate efficiently and provide the best possible user experience. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.